Hello guys. So today we are starting with the mole. If you like math, you're going to love this part. If you don't like math, you're not going to love this part. And you are going to need your calculator and you are going to need to be able to do exponential notation on it. Just a warning. So anyway, atoms are too small to weigh. I think you've all figured that out, right? Atoms too small to weigh. As are molecules. They're also pretty darn small. So scientists weigh a whole bunch of them, a large number of them, at one time. And to be consistent, they try to weigh the same larger number all the time. And that larger number, which is always used, is called the mole. Well, what the heck is a mole? We discussed this in the beginning of the year when we were talking about the amount of a substance, when we were talking about SI units, and the amount of a substance was the mole. And it is equal to 6.02 times 10 to the 23rd particles. This is an incredibly important number. You need to memorize this number. You need to make sure you have the power of 10 right. It's positive 23rd. Your book may have 6.023 times 10 to the 23rd, but we're just going to use three significant figures. Okay, these particles can be literally anything. They can be atoms. That makes sense. It's a chemistry class. They can be molecules. They could be electrons. They could be cookies. You could have a mole of moles, the little furry, nearly blind animals that live underground. You could have a mole of those. There's a video I used to like to show you, but it's now been taken offline everywhere, and it shows you that if Los Angeles was covered by a mole of sand, that it would be, forget, something like 2,000 feet deep. I mean, it would go over the top of Palos Verdes, the sand. That's a lot of sand. So this number, 6.02 times 10 to the 23rd, is so important it has its own name and its own symbol. It's called Avogadro's number. And and I can hear you all now saying avocado's number as opposed to Avogadro. And that's fine because Trader Joe's actually has a ready-made guacamole called Avogadro's number guacamole. So you are not the first, nor will you be the last people to think of that. Anyway, so this number is called Avogadro's number, and it is given the symbol uppercase N. Okay? So if you see an N someplace, or an N0 someplace, it is Avogadro's number. So the mole is a unit of measurement that's supposed to be one word. And it's very similar to the dozen, except it's a whole lot bigger. So we use it the way you would a dozen. If you have 3 dozen cookies, how many cookies do you have? Well, you guys all know that 1 dozen, the abbreviation for dozen, equals 12, right? Whether it's eggs or cookies or sticks of butter or kumquats. Okay, so what we would do is we would take our given 3 dozen cookies and we'd multiply by 12 cookies for every 1 dozen. The units of dozens would cancel. You'd multiply 3 times 12 and you would get 36 cookies. So as you can see, the dozen can be thought of as a conversion factor. You can do the same thing with the mole. If you have 3 moles of argon, how many atoms do you have? Well, you'd start with 3 moles. And we know from this equality, well, I guess I didn't put it as an equality. Yes, I did up here. 1 mole, or the mole. We maybe should rewrite that as 1 mole equals. This then is a conversion factor. 1 mole is equal to 6.02 times 10 to the 23rd particles. So down here I have moles. I want to know how many atoms of argon I have. So my particles are going to be atoms. So I want to get rid of moles. So I'm going to put moles on the bottom. I'm going to put Avogadro's number, 6.02 times 10 to the 23rd atoms on top. The units of moles cancel. 3 times 6.02 times 10 to the 23rd is 1.806 times 10 to the 24 atoms. You can use this in reverse as well. If you have 1.202 times 10 to the 24th atoms of argon, how many moles do you have? Well, you'd start with the number of atoms, 1.202 times 10 to the 24th. Actually, that should be 1.204. Otherwise, it doesn't work out nicely. Atoms. Sorry, I'm running out of paper here. We look at Avogadro's number. We want moles, so we want moles to be on the top. 1 mole is 6.02 times 10 to the 23rd atoms. Okay, so what I'm going to do is take this number, 1.204 times 10 to the 24th, and I'm going to divide by Avogadro's number. The units of atoms will cancel, and I am left with 2 moles. So Avogadro's number is a conversion factor. Okay, so here it is written as a conversion factor. It allows us to go from moles to atoms, molecules, or cookies if we want. And you can write it as 1 mole over 6.02 times 10 to the 23rd atoms, etc. Or 6.02 times 10 to the 23rd atoms in 1 mole, depending on what you're looking for. You can do it for molecules as well as for atoms. So let's do a problem. 3.3 moles of water. And the problem says, how many molecules are there? Okay, well, there's 6.02 times 10 to the 23rd molecules in a mole. So I'm asking for moles. Whoops. Divided by 6.02 times 10.
Nope.
I did that wrong. I am looking for molecules. 6.02 times 10 to the 23rd molecules over 1 mole. So I'm going to multiply 3.3 times Avogadro's number. 3.3 times 6.02 second EE 23, enter. Gives me 1.99 times 10 to the 24th molecules. Okay, so ignore all the scribble. I have the unit I want to get rid of on the numerator, and in the denominator, multiply those two together and I get that. On the other hand, if I want to know how many moles are in 3.03 times 10 to the 23rd atoms of sodium, I'm going to start with my atoms of sodium. 3.03 times 10 to the 23rd atoms. I know Avogadro's number. I'm going to look up here. Okay, I want moles on the top. And I want atoms on the bottom, so they will cancel. And I'm going to use this as the conversion factor that I need. 1 mole in 6.02 times 10 to the 23rd atoms. So I'm going to take 3.03 times 10 to the 23rd and divide by 6.02. That should give me roughly a half mole, but I made up my number kind of weird. It gives me 5.03. 5.03 moles. Or we can just call it 0.5 moles. Okay, so that's using Avogadro's number. We're going back and using the molar mass later.